to ACE Engineering Academy online platform where we are having ACE Preparation League Season 2. My name is Abhishek Sharma and in today's session we are going to discuss important concepts from data structure. So yesterday's session we have discussed the preparation strategy for data structure. And in today's session, we are going to discuss concepts, and definitely in that concepts, there will be some question solving in this case. So I have brought down the today's agenda, and here we have this. I have picked up this from from the topic which is in syllabus, like this particular concept of row measure ordering for a lower triangular matrix. I have picked this topic from this array. So now here the row measure ordering of lower triangular matrix. The next I have picked up expression tree. Okay, now we have very close relation of the infix expression, then expression tree, and then it is also possible to draw the expression tree from prefix and postfix expression. And we know that this particular topic is from the subject, this particular topic is basically stack. The third concept I will discuss here in this case is a topic from queue, where I'll be discussing the concept of how to implement a queue by using a stack. And here operation that I'll consider in this case is with reverse operation. So if a stack is having a reverse operation, then how we are going to implement the queue. That is my third concept here. So array, queue, and array, stack, and then queue. The next concept I have taken one of the important concept which is in post order and pre-order, for special cases. We are aware that we can draw the tree with in order and pre-order, in order and post order, but it is also possible to draw the tree by using post order and pre-order, but not in all cases, but in some special cases. So here we are going to discuss that particular topic, that from tree, the tree construction using pre-order and post-order traversal, some special cases. Not only pre-order and post-order, but in some special cases you can draw the tree only by considering post-order and pre-order. Okay, post-order and pre-order. So in some cases we can draw the tree with post-order and pre-order, and same thing goes with binary search tree as well, that we can draw the BST by post-order and pre-order. So that method that we are going to see, this is one of the important concepts. Then we will see one of the method which is in this case is heap counting. So I have selected this 5 topics over here for this different corner of the syllabus, that array, stack, queue, then tree, and then binary heaps in this case. Okay, so I guarantee that this session will be really helpful for you and you are going to enjoy thoroughly this particular session. Okay, so let's start with the first concept here in this case is the lower triangular matrix. Now, this is a lower triangular matrix, and in this case I don't need to define it, but still the definition is here. The square matrix is lower triangular if all the entries above the main diagonals are 0. Okay, so now here already I have just I have this matrix over here that is in this form, and we call this diagonal, this is our main diagonal here in this case. This is main diagonal. This diagonal, there is another diagonal, but this diagonal here in this case called is a anti-diagonal. Okay, this diagonal is a main diagonal and this one is an anti-diagonal in this case. So now we want all the element in this above the main diagonals are 0. Now this is one of the sparse matrix. This is one of the sparse matrix, and sparse matrix is a matrix, sparse matrix. Now if you have a sparse matrix, then here we have relatively few non-zero entries out there. As you can see here that we have relatively few non-zero entries. Okay, so like here in this case, if you want to say how many elements are there, we can count it. You can see that how many non-zero elements are there, we can count it. You can say the number of what is the condition for which 0 and 1, we can have this. So now Here elements will be the number of non-zero element in this case. So let's count this value first. Number of non-zero elements. So number of non-zero element. So here number of non-zero elements will be counted in this way. Now you look at here, the first row consists of one element, second row 2, then third row 3, and fourth row 4 element. The number of non-zero element will become in this case is 1 plus 2 plus 3, and up to this value will go for n equal to 4, and for generalization it will be this. Now here in this will become equal to n into n plus 1 divided by 2. So this is the n equal to n plus 1 divided by number of non-zero element. How many zero elements are there? How many zero elements are there? So number of zero element in this case is number of zero element. So like non-zero, there is also zero elements in this cases. The number of zero elements. Now you can compute in total minus non-zero. So this is one way of doing it. The total here in this case is n square minus n into n plus 1 divided by 2, and that is equal to 2n square minus n square minus n divided by 2, and that is equal to in this case is n square minus n divided by 2, and that is n into n minus 1 divided by 2. So that is your number of non-zero element. So now we have number of zero element as n into n plus 1 divided by 2, and number of non-zero element will be n into n minus 1 divided by 2. What is the condition for which value will be 0 in this case? This is also one of the very simple concept and simple question related with array. You can have the arrangement of array in many different ways, but these conditions are like logical testing, that for what value this I and j will be equal to 0. So now your observation again that 2 1 is 0, okay, 1 2 is 0, 1 3 is 0, 1 4 is 0. Okay, then here 2 3, second row third column is 0, 2 4 is 0, and 3 4 is also 0. So you can see here that the moment j becomes greater than I, if j is greater than I, then we can say the element is 0. So for all condition a I j is 0 if j is greater than I. Okay, so a I j is equal to 0, a I j is equal to 0 if j is greater than I. If that is the condition, then the value will be 0. Now, here we are having the concept of row measure ordering, and here to save the space, what we are going to do, we are not going to store these 0 values. So we are going to map this two-dimensional matrix, okay, this two-dimensional matrix into a single one-dimensional matrix in this case is one-dimensional matrix. So here we are going to map this 2D matrix to a one-dimensional matrix, but we are going to store only the zero element, non-zero element. One-dimensional matrix, and we'll store only the non-zero element in this cases. The non-zero elements will be stored. So now if I just say that how this is going to be stored, so this will be mapped here in this cases that aij first row consists of one element, then we are going to have the 2 element over here, then we are going to have 3 element over here, this is row 3, and then we are going to have 4 element over here. So this is a one-dimensional mapping here in this case. Now, I want to find of address of A43, and with this address of A43, I will also generalize the generalize address, or you can say index also. Okay, index also for this values. Like here you can start with index 1, 2, 3, 4, 5, 6, 8, 9, and 10. There are 10 elements are there. So that also you can define that at which index it will be present or which address it will be present. Now understand that before coming to the 4th row, we have already done with the 3 rows. So before 4 row, okay, before 4th row, okay, 4th row, 3 row completed, okay, 3 row completed. Now, if I say that 3 row completed, then how many element in each row? So you will see here that, like here, if I want the address here for this 4 and 3, and before coming to this, I have completed number row 2, and the 3 row I have already completed. And here, of course, the whole calculation that I am doing for lower bound 1, but you can have any bound here in this case, lower and upper, as long as it's a square matrix. So before 4th row, we have completed 3 row completed, and the number of element in 3 rows, number of element in 3 row, okay, 3 rows will be what in this case is the first row consists of 1, second row consists of 2, third row consists of 3. So 1 plus 2 plus 3, this is the element. The 3 row consists of 3, 1 first row first, second row 2, and third row 3 element in this case. So now that makes here in this case is total number of element 3 to 5 plus 1, that is equal to 6 element. So 6 element row wise I have completed. Now come to the column part, that J part. If you are in the jth column, this is the jth column again. This is the, I am in third column. This is the column 1, this is first column, second column, and the third column. If you are in the third column, then you have already completed 2 columns. Why? Because the lower bound again in this case is 1. So 3 minus 1. 2 element completed in this case. So if you are in, like here I'll write this thing that if you are in the third column, then 2 columns completed. So for this 4, this is the 4 and this is the second part, third. So if we are in third column, then 2 columns, then 3 minus 1 column is completed. 3 minus 1 column is completed. That is equal to 2. And number of element, each column will consist of only 1 element, because we are counting only, not the all element, do not count. So row wise, and this column 1, column 2, and column 3. So 2. So total how it becomes 6 here, 2 here, total it becomes 8. Okay, total it becomes 6 plus 2, that is equal to 8 element we have already done. Now question is, what is the address? So now here in this case is, we have a base address which is equal to 1000 plus number of element arranged is 8, and multiplied here, I haven't mentioned this thing, but again it was obvious that this address starts with 1000, that is your base address, and the size of each element in this case is 2 bytes. So now here this will applied here, and 8 into 2, that is equal to 1016. 1016 is the answer for this. This is the address here. And now you can see that this part here, look at this address which is manually A43 is 1016. So if we have this, and now I want to find the row measure ordering for this A, I, and J, where this is a generalized answer, Aij address in a row measure order, okay, and with the lower bound in this case is for n cross n matrix, for n cross n matrix. So now same, if I am in ith row, I minus 1 row completed, right? For ith row, this is the calculation for the ith row. So if you are in ith row, I minus 1 row is completed. I minus 1 row completed. I minus row will come, number of element will be number of element in I minus 1 row will be equal to 1 plus 2, and up to third row consists of 3 element, and similarly I row will consist of I minus 1 element, and that makes it I into I minus 1 divided by 2. So this is the element that I have completed row wise. The first row consists of I, second row consists of 2, third row consists of I minus 1 element. So I into I minus 1. I know here the lower bound in this case is 1, and that's why the formula become I minus 1. What will be very interesting if you say that what will happen if there is a generalized bound. Okay, so we'll just see after this that what about the, if I have a lower bound, but just make sure that it is a square matrix. Okay, it is a square matrix, that both the dimensions
All India rank 1 in ESE 2021 from E&T branch. I took ACE postal course, mains test series and interview guidance program in ESE 2020 and ESE 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India rank 1 in Mechanical Engineering in ESE 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself Abhishek Sharma. I have scored All India rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India rank 1 in ESE 2021 from E&T branch. I took ACE postal course, mains test series and interview guidance program in ESE 2020 and ESE 2021.
Hello everyone, my name is Karthikeya Kaushik and I have secured All India rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India rank 1 in Mechanical Engineering in ESE 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, postal study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests.
I have scored All India rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESE 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESE 2020 and ESE 2021.
Hello everyone, my name is Kartikeya Kaushik and I have secured All India Rank 1 in UPSC Engineering Services Examination 2021 from Civil Engineering discipline. For prelims preparation, I took online test series from ACE online platform and used to regularly solve their subject-wise test and full-length test. Then for mains preparation, I solved question banks which were given to me as a part of mains postal program from ACE Online. And then last but not the least, for interview preparation, I followed the interview guidance material which was given to me as a part of ACE Online's interview guidance program.
I am Vinit Kumar. I have secured All India Rank 1 in Mechanical Engineering in ESE 2021. I have been associated with ACE Engineering. I have taken various programs like Lives, main classes, Postal Study course, test series and interview guidance program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now, I divide my preparation strategy into three basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve
program. So would like to thank all the faculties of ACE. It has helped me in building my concepts and having my fundamentals cleared. I would also like to highlight that in test series, I have given various mock tests which have helped me in the time of real exam, and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
myself, Abhishek.
Okay, sorry for the inconvenience, and now we are again back. There is some technical issues related with this internet connection. That is actually usual nowadays. But sorry, let's continue. And here the next concept that I'm discussing here in this case is for the expression tree. Okay, and expression tree, and this expression tree is basically you learn a lot in case of compiler design, that expression tree, and also it is called as syntax tree. The condensed form of the parse tree is called as syntax tree. So we only keep here in this case the operators mainly and operand, and we ignore the rest of the non-terminal and all the chain of lines. So we reduce that into a condensed form of the tree, and that is syntax tree. And it is very natural that we can get from a given expression, we can get the expression tree. So A plus B multiplied by C. Now, we know that for evaluating the expression which is in prefix or postfix form, the precedence is very important, because that set up the which will be go first, which will be go next. So here we know that multiplication is having higher precedence, and I'll draw the expression tree in this multiplication, and then in this case is B and C. Then we have plus, and in this case we can have this as A. So A, B and C. This is called the expression tree here in this case. This is called expression tree. This is the expression tree. So now with infix using simple the precedence and associativity, we can find out. Now my point is, can we find out the expression tree from the postfix or prefix expression? So here this is the postfix expression, and can I draw the entire expression tree with using this postfix expression? So answer is yes, and here we are using the concept of evaluation of postfix expression. Evaluation of postfix expression using stack. Using stack. So now here we are using this concept, evaluation of postfix expression using stack. Now what will happen in this is your terminals, the operand and operator, A, B, C are operand. The operand will come A, B, C and D. Okay, A, B, C, D. These operands are coming here in this case. Now operands are coming A, B, C, D plus multiplication, F division plus G multiplication and then plus. So these operands are coming A, B, C, D. Then first come the operator which is plus. To evaluate the postfix expression, now think of a situation where we have this stack over here, and that stack is just tilted 90 degrees. So this treat is as a stack. A, B, C, D, the first time plus will come. Top two operand will be here popped out, and we will evaluate the expression, and here in this case we will create the tree in this case. So the moment plus come, plus become the internal node, and we pop the two operator which is evaluation of the postfix expression, and we create an internal node. Then comes multiplication, and the same thing will do, that we pop two operator, but now this is already done. So top two operator will become B and then C, D together, C plus D together. So now here when we have a multiplication, now again the top two operator will be this and then this. Then comes your F. So now I will write here in this case is F. Then comes division in this case. Again the same thing, you pop two operand and put it over there. So this is division, and now the top two operand is this and F, this. So now you see that slowly the tree is in, construction is in progress. For better understanding, I'll just erase this statement from here, which is nothing but it is equivalent to your postfix expression evaluation. Now, division. Now there is a plus. So now plus comes, then again this entire part is evaluated. So plus will go here, and the first operand is this, the top operand, and this there is a next operand. So now we are done up to plus. Then GE multiplication. So now we have operand, so G, E, and then multiplication. Now again pop two operand and apply the operation. So multiplication here with G and E, and then we have a finally plus. So plus, now I have two trees are there. Now they have already grown up to an expression, and when the plus will come, this plus will be here, and this will become your operand. This is the expression tree from the postfix expression. So effectively what we have done, we are just using the concept of evaluation of postfix expression, and rather than evaluation. Rather than here in this case is evaluating, what we are exactly doing here in this case is that we are creating trees where the moment operator will come, I'll pop two operand and create a tree. That time now C plus D now will become an operand, and I'll treat them, this small expression, sub-expression, as a operand. Just to demonstrate that A is coming, B is coming, C is coming, and then D is coming, these are operand, then plus comes, now we'll join C and D. Then multiplication comes, this expression becomes an operand and B also becomes an operand, and in this case we join them together. Then comes your F, created. The next operator is division, so I'll create an internal node for division, and F will become, and this subtree will become their operand. Then there is a plus. So the moment plus will come, now this entire expression in A, the second operand, single operand A is there, and that will become in this case is the expression. The next is plus you are done, so G and E, so G and then E. Now here there is a multiplication, so there will be multiplication, and now they will be joined together. Finally we'll get a plus, and in this case we can join this, and our expression tree is completed. Okay, so this completes our expression tree here in this cases. We can convert from infix to expression tree possible, and prefix to expression tree is also possible. Postfix expression I have already demonstrated. Now you might be wondering what to do when we are having the prefix expression. So now here for prefix expression, you need to scan the input from right to left. From right to left. Okay, right to left. So now here, then what we will be saying that what was this? So now for this expression, I am scanning from this side to this side. And that is scanning becomes left hand side to right hand side. Now for prefix will come from the right hand side to left hand side, and here like here in this case when you scan an expression A plus B, so this is the first operand, and that will call it as operand 1, and this is the second expression that is called operand 2, operand 1, and this is your operand 2. So if this is the operand 1 and this is operand 2 in this case is, then if you scan from the left to right, then the top will be operand 2 and the top minus 1 will be operand 1. But the same thing when goes from right to left, the top will become operand 1 and top minus 1 will become operand 2. That is the only difference that we have here in this case. Otherwise, we can evaluate it without any problem. So that is the concept here in this case. Huh? Now, here we have the last concept here in this case because we have out of time, the agenda not able to fulfill here in this cases, but still. Now here we have few special case where we can use the post order and pre-order traversal and we can get the expression out of it, the tree out of it. So now this is the next part here is getting the tree from the post order and pre-order traversal. Now the special case that I am talking about is that if each internal node of the binary tree has at least two children, at least two children. Okay, now here in this cases, here internal node is having at least two children. The meaning in this case is that every node, okay, every node is having either 0 or 2 children, 0 or 2 children. At least will applicable, but here because it's a binary, you cannot have more than 2. So there is no point of saying at least 0 or 2 children. Okay, so if that is the tree, that we call it as a two-array tree. Okay, that we call it as a two-array tree. So if it is a two-array tree, then we can have the tree back. Now for that, I have a order here in this cases, and I'll demonstrate how it is possible. So here, let's manually do this thing that we have a post order and pre-order. Now we know for the pre-order, this is the root, okay, root. And for post order, A is the root, and there is no confusion that A is the root of the tree. A is the root of the tree. So no one will deny this thing. Then if you look at the pre-order traversal, then you will find the sequence for the pre-order is root, then left and then right. Root, left and then right. This is the sequence that you have for pre-order. And for post-order, the sequence is what? For post-order, sequence is left, right and root. Left, right and root. So here it is okay for the root, that root is this, but understand that A is an internal node and it is having two children. Who will be two children? So for pre-order traversal, after root we visit the left, and that means B is on the left. We will go to the left child. I know it is an internal node and it will have two children. So we will go to the left and visit the root. In this case, that is B. And for post order, before visiting the root, you are going to visit the right children of it. So now here A followed by B, B is on the left. E before A, E is on the right. This is the situation here in this case. Fine. So now this is something that left and right children. Second, how to identify the leaf node in this case. Now you understand that here you are visiting a node in pre-order and then its left and right children will be visited. So first root, then left and right children. And here you are visiting the root and before that its left and right children will be visited. Very simple logic. In pre-order, first root, then left and right children. In post-order, first children and then root. Now here in pre-order, in this case, you can see here that in post or in pre-order, first E will be visited, then its children left and right will be visited. Root, left and right. So who is the root? E is the root. Then left and right children will be visited in this case. But after E there is nothing, and that means here E is the leaf node. Why? Again I'll say that here after root you will visit left and right, after E we are not visiting anything. E is the leaf node. Now we have a sequence where we have identified this situation B, C, D, F, G. So let's write the sequence B, C, D, F and G. And here apart from E and this, C, F, G, D, B. So C, F, G, and in this case D and B. B is the root, B is the root, fine. Now B is having a nodes here in this cases, and now we can say the same rule for left and right, that after B you are going to visit the left children, root and then left. So C is on the left, and before B we are going to visit D, and D is on the right. So there's C and D in this case. Now identification of root here in this case is that here you will again say that which one, C and D, is it any one is a root or both are having its children in this case. So now again after root, after C, the children apart from B, after C you are going to visit the left and right, root then left and right, and after in this case is D, okay, after in this case is D, you are going to visit root left and right here in this case. Now, but here we are identify one thing, that in pre-order traversal, after C directly D is coming, and also identification that we are visiting left and right, then we visit the root, and in post order what is happening, directly C is coming, and that means before C no element is visited. And these two analogy, highly logical conclusions, that after C D directly coming, left and then directly right child is coming, and before C nothing is there, that concludes C is a leaf node in this case. So now it is having two children and C is the leaf node. So what we are left with, B gone, C gone, and in this case D, F, G. So D, F and G, and another one is in this F, G and D. F, G and D. So now D is the root, and after root we are going to go to the left for pre-order traversal, which is F, and before D we are going to visit the G, and that will be on the right. So now this is my tree that I have constructed by using pre-order and post-order traversal here in this case, pre-order and post-order traversal. So the idea here I'll summarize the idea that if it is having two array tree, that every node is having 0 or 2 children, then it is guaranteed that after root you are going to visit the left, before root you are going to visit the right in post order. Second concept that I have heavily used in this case is leaf node. Then first, how I identify E in this case is that after E in pre-order traversal, root then left and right. E is the root and it's having a left and right children. So in pre-order traversal, they will come after E. But in pre-order E, there is a blank, nothing is there, last symbol. That means E is the root. What about B? So now I have, with this E, I have carry forward the post order and pre-order traversal. This is your post and this is your pre. Now again I identify B is the root, C on the left, D on the right. Now C and D. So observation in post order, how to identify the leaf in post order is that in post order you say that before C, like here in pre-order after C, before C the element must be visited. So first left and right of C will be visited, then you come to C. But here you can see that in post order only C is there and before that no element is there. And with that we can conclude that C is a leaf node, and I carry forward D, F, G and F, G and D. Whatever statement I am saying, if it is not making sense, try to watch it again and see that how we can conclude into a tree that one node, a given node may be a leaf node. So that is the concept related with special case where we can reconstruct the tree using pre-order and post-order. So that's it for the today's session. Important concept. I want to cover more definitely, but I could not. Maybe next time when we have the YouTube session, the remaining part of this will be definitely conducted. Thanks for your time, and I hope that whatever we have discussed, the concept over here is fruitful from your point of view and you enjoyed the session. Thank you very much for watching and giving your time. Best of luck for the upcoming examination. Thank you.
In the time of real exam and in interview guidance program, building confidence in front of interview panel. It has helped me in my success.
Myself, Abhishek Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you.
My name is Kuldeep. I have done my BTech from Ambedkar Institute of Technology, which is situated in Delhi, and I have secured All India Rank 1 in ESE 2021 from E&T branch. I took ACE Postal Course, Mains Test Series and Interview Guidance Program in ESE 2020 and ESE 2021.